Today we're going to take a look at systems of equations and how we can use systems to, we'll build off of it in finding how to find a solution to the systems. That's going to come up in a later video or a later lesson. Today we're just going to take a look at how do we characterize and describe a system of equations or a system of problems. So let's start off with some review here. A linear function is a relationship between the independent and dependent, or x and y variables. Okay? It can be characterized as a y according to x. So how is our dependent variable in relationship to our independent variable? How is it changing? And we use slope to do that, and then we can use other equations to represent that as well. Or we can also think of it as the y value is dependent on the value of the x value, or the x term in our point. Okay, I used the example, and I've used it in class as well, of a gas station, right? So our y value is the cost that we're going to pay, and the x value is the number of liters we put in. Well, the cost is dependent on how many liters we put in. Okay, it's a linear equation or a linear relationship. Now, we can also find the x using the y, but that's something completely different. So we just remember that the y value is what is based on the x. These relationships that we have here can be thought of as an equation which uses an independent variable x and a dependent variable y. Now, sometimes they are completely just correlate. If we think of like the number of students, and our two characterizations are the students with hats and students without hats, well, one's not dependent on the other, or maybe they are, because if you don't have a hat, it's dependent on if you have a hat or not. That's something completely different, but we can think of it as the two are related to each other and dependent on each other. Now, in the previous lessons, you've learned two different forms of describing lines. We've learned graphics form, which is y equals mx plus b. We've also learned slope point form, which is y is equal to m x minus x1 plus y1. Okay. We've also kind of looked at how can you just use two numbers to give you a value. And today maybe we'll even take a look at how do we compare two values as well. To determine if a function is, if it is a linear function, the x and y variables will be singular, which means no exponents. That is a grade 11 topic. When we start dealing with exponents, and we move more into it in grade 12 as well. So we always just have x all by itself, x and y all by itself. Now, a line can be described as a function as well. It can be made using the slope and any point along the line. Sometimes the slope isn't given, so it needs to be determined using two different points. So we have to determine what the slope is using two different points. Sometimes, other times it's given. We can think of it as, remember, this is also the rate of change. So if we're given a rate of change or something that is kind of affecting the way that things change, that's going to be our slope. So in this video here, we're going to take a look at how do we describe a situation, okay? And how do we kind of come up with our solution? And again, the solution is going to be more of, for next lesson, this one's going to be more just coming up with a situation using an equation. So here's our solution or situation here. Two numbers add up to 16. We're going to create a formula to represent the solution, and then we're going to graph the function. The first thing that we're going to do is we're going to define the variables. Okay, so x and y. What are x and y? Well, there's not a ton of kind of context to these. We're just told that we have two numbers that add up to 16. So x can be the first number, and y will be the second number. Okay, so let's define the variables. Okay, we can determine if anything is being multiplied to the variables. In this case here, it's strictly just, we just have x and y. And we can then create a equation, x plus y is equal to 16, because the two numbers add up to 16. Okay, so they add up to 16. Now, If we want to, let's say, change this into graphic form, okay, so we can graph it out, what we can do is we want to get y by itself, so we're going to subtract 16 from both sides, and it's going to be y is equal to negative x plus 16. So we can do that as well, and come up with a solution that way as well. Okay, so that's one way, and then we can graph this out, and we'll take a look. We'll graph it out. I'm going to draw a graph that looks something like this here. Here is the y value. Here is going to be our x. We'll go down a little bit. Okay, and once I graph it out, you'll kind of see why I'm maybe doing this. I'm going to go up by 2s, so we have 4, 8, 12, 16, 4, 8, 12, 16, 20, 24, negative 4, negative 8, negative 4. Okay. All right, we'll graph this line out, graph out the solution here. We have a y-intercept of 16, a slope of negative 1, so it means we're going down 1 over 1, and because we're going up by the same value, we can do that. Draw a line through. Which is going to look like that. And there is our line, x plus y equals 16. There we go. I just had it off the screen a little bit. So that's one way that we can graph it out, and we can figure out where our points are. Another way that we can do it is we can create a table of values, our x and y. Let's come up with some values of x. So let's say we have 0, 4, 8, and 12. And again, I'm using those because they're going to be nice values here. 0 plus 16 gives us 16, 4 plus 12, 8 plus 8, and 12 plus 4. That means that we would have this point here, 0, 16. We would have 4, 12 is this point right here. 8, 8 right there. And 12, 4. These are all points that are on the line because they work with the equation. And then that will graph them out. We would draw then a straight line through there. So we can either create a table of values, plot them, draw a line through. We could move our equation into graphic form, and then we can graph that out from there as well. Now, the other thing to think of is also domain and range. Domain in this case here, x can be all real numbers, okay, because every number works. There's no context that says it can't, and y will also be all real numbers when we put it in there. So there's an equation. There's giving the variables, okay, creating the equation, coming up with some solutions that work, graphing it out, and then the domain and range is given there as well. Now, a system of equations. So a system, that was just a singular equation that we just did. A system of equations, okay, represents two or more equations, okay, which are used to solve a problem. So maybe we have two different scenarios that need to be met in order for a solution to be made, and then we're going to have a very singular solution to it. Okay, so again, this is when there are two or more scenarios, okay, which need to be solved. Okay, two or more scenarios that need to be solved. So I'm going to just give an example. Let's say that I'm making a fruit salad, and I want 24 pieces of fruit between apples and oranges. I'm going to do apples and oranges in my fruit salad, and I want 24 pieces of fruit. Okay, so x plus y is 24, right? So we'll have to have a combination of 24. And then let's also say that I want twice as many apples as oranges. Well, I have to then figure out what would be the value if there are twice as many apples as oranges in order to solve that system. Okay, so that's two different scenarios that are at play and trying to figure out our answer. Now, the two lines that we have are going to meet at some point. Okay, and this is the solution to the system. And again, we're going to discuss that in the next section. We're going to look at that at LI 7. We're going to take a look through what that, in that kind of situation we would have there. So let's do an example where we have two potential solutions. Or sorry, two potential scenarios which are going to try to guide to our solution. Here's our example. A school bus has two different sizes of buses. Okay, one bus can carry 30 passengers, the other can carry 48. So we would have a small bus and a large bus. The total number of passengers the school division can carry is 1,500 on its 35 buses. How many of each bus does the division have? All right, well, a couple things that we don't know, and these are going to be our variables. So we're going to start with our variables, defining our variables. Okay, oh, sorry, we're going to skip that for just a second there. The two problems that we have is we know the total number of students is 1,500, okay? And in relationship to that, there are 35 buses to carry students, okay? Now here's the thing, we don't know how many of each bus there are, and in relationship to that, we don't know how many students are going to be on each type of bus. We know there's a total number of students and we have a total number of buses, but we don't know how many of each bus there are. So that's going to be our variables. We're going to define our variables. Our variables, X is going to be the number of large buses. Okay, these are the 48 passenger buses. And Y is going to be the number of small buses. Okay, these are the 30 passenger buses. Okay, and I'm going to define them that way. Now, we want to try to figure out what are our two, how can we represent both of our scenarios, or kind of our problems that we have, using these two here and writing them out as an equation. I'm going to start with the second one just because I find that one to be a little bit easier. Okay, there are 35 buses to carry students. We know that X is the number of large buses and Y is the number of small buses. So in this case here, we're going to know that X plus Y is equal to 35. Okay, they have to add up to 35 because there has to be they're going to add up to that. That's how many total buses we have. Then on the other side, okay, we want to figure out how many students they can carry. So somewhere here we have to come up with the number of students. Well, in this case here, it's not going to be a graphic form or slope point form one, but we can take the number of students on the large buses plus the number of students on the small buses, and that has to equal to 1,500. So this here is going to be the number of students on large buses. That's going to be this section here, and I'll show you how to do that in just a little bit. And this section right here is going to be the number of students on small buses. To figure out a question like that, to figure out the number of students on large buses, you've got to take the number of large buses and multiply by the number of students that are going to be on there. Number of students on the small buses, we take the number of small buses and multiply by the number of students on the small buses. Now we could put this into graphic form if we really wanted to, but we don't necessarily need to, and I'll show you ways of solving without doing that. We'll do that in the next lesson. But that is how we would come up with our equations that represent our problems. Now we can again do domain and range as well. We're dealing with people, so we can't have negatives, we can't have decimals, so we're going to use whole numbers, and number of buses. We're not dealing with people in this case. The number of buses are X and Y, so we have whole numbers, and for range you also have whole numbers as well. Now if you're following along with my class here, or you're in my class, your assignment is LI.06, numbers 1 to 9, coming up with equations in order to solve for problems. We are not going to do the solving part quite yet. We're just doing coming up with equations. Remember, what is X and what is Y? What are the equation or equations? Come up with a solution if you want to, but we'll do more of that later. And then make sure you give the domain and range of the problem as well.